So here we have a boat that is, of course, in the water, and then we're looking for fish. And we have there are some boats that have this tool called a fish finder. And the fish finder basically is a tool that sends out sound waves down into the water, and they will bounce back to the device, and it'll calculate the time between when it hits the fish and comes back, and it'll be able to determine if there's fish or not just by bouncing waves off of them. The maximum distance for this particular fish finder is up to 85 meters deep. Otherwise it won't work. And the question is, what is the time between the minimum time between pulses if the maximum distance is 85? So what we can do to figure that out is we can actually just look at just the speed equation, which just says that the speed of something is going to be distance over time. The question though is, so we're looking for time, so I'm just going to solve for that. I'm going to multiply t on this side and then divide by v on this side. So it'll be distance over velocity or speed. So I'm going to use this equation to calculate time. Now here's the tricky part. The distance isn't actually just 85. The distance is actually going to be 2 times 85 because the waves have to go down and then they have to bounce back. So the distance will actually be 2 times 85, which is 170 meters. So that's what we're going to plug in here. And the speed actually isn't given to you in the problem, but if you look up in a table, I think in the textbook, or you can Google it, the approximate speed of sound in freshwater is 1,450 meters per second. So let's go ahead and plug this all into the equation. So distance is 170 meters, and the speed is 1,450 meters per second. When you put that in the calculator, what you're left with is t is equal to 0.117 seconds or 0.12 seconds. That's the minimum time between pulses.